Hey, this is Dan Berglund, and I'm showing you my project for my Udacity Self-Driving Car Engineer Nanodegree project. What's happening in this project is that Udacity's built a little simulator environment using just a video game engine like Unity that allows a car on a track to drive around. So I've driven this car around just using the computer, and I record images in the training mode, and then I have built and trained a neural network in Keras that allows it to drive itself. So let's get this started. So I'll launch the autonomous mode. Down here I will launch my Python file that loads up my neural network with Keras and loads all my weights for my neural network. So what's happening here is that these steering values are negative when you're turning left and positive when you're turning right, and this 0.2 is just a constant throttle, so there's no speed control effort in this. So how it's driving right now is that there's a camera on the dashboard that's being fed into the neural network, so the car and the neural network did not see what we're seeing right now. So when it was training, it's the same thing. There was a central camera and then a left and right camera that collected images, and those images were fed into a neural network for training data, and this is the result of that trained neural network. So right now it's taking images, feeding it into a pre-processing algorithm that I created, and then feeding that pre-processed image into the neural network. So some key things is that it resizes that 160 by 320 image down to a 64 by 64 pixel. It pretty much drops off all images above the roadway, and the dash camera, you can see the hood of the car, so it cuts that out as well. And it also converts it to HSV, which I found works a lot better than RGB. The saturation channel seems to have a lot more information about what the roadway is and what's everything else. So yeah, this is a 5-layer neural network. It has a 1 by 1 by 3 on the front to let it select which of the HSV channels it wants to use. It has a 3 by 3 by 32 two-dimensional convolutional layer, followed by 2 by 2 max pooling and dropout. So then it has another of the same thing, so it has another layer of 32 layers deep, or 32 filters in 3 by 3, and then there's another max pooling and dropout. And then the final convolutional layer is 64 filters, all in 3 by 3, and then again max pooling and dropout. So that's flattened, and then that's connected to a fully connected layer with 20 nodes, which is in turn connected to the final output, which is just a single value that outputs the turn angle. This was trained with 40,000 images per epoch, and then 10 epochs, and it has a batch size of 256 images. So that's my project. Thanks.